Welcome to Demystifying Math. In this lesson, we're going to be graphing the sine function. Let's start at the beginning. We have an isosceles right triangle, which means that the two legs of the right triangle are the same length. We're going to let the hypotenuse have a length of 1. Now we can find the legs of the triangle by using the Pythagorean theorem. So A and B are legs, so we're going to replace those with x, and C is the hypotenuse, so we're going to replace that with 1. Then we isolated x and we got square root of 2 over 2. So that means that each of the legs are square root of 2 over 2. Now the base angles must each be 45 because the three angles of a triangle must add up to 180 and one angle is already 90. So we're going to take the remaining 90 and divide it by 2 to get the 45. Now what we want to do is find the cosine and the sine of the angle 45, which is theta on the drawing. So the cosine is the adjacent over the hypotenuse, which gives us square root of 2 over 2 divided by 1, or just square root of 2 over 2. And the sine turns out to be exactly the same thing. Now what we've done is taken that isosceles right triangle and embedded it on the coordinate plane inside the circle that is a unit circle of radius 1, centered at the origin. So that means that the ordered pair, square root of 2 over 2, square root of 2 over 2, is going to fit the equation for that circle. And you can plug in those values for x and y and verify that. Okay, so remember the legs of the right triangle were square root of 2 over 2 and square root of 2 over 2. So that's our x value and our y value. And remember also that we found that that turns out to be the cosine of the angle 45 and the sine of the angle 45. So on the coordinate plane, x is representing cosine 45 and sine is representing the y value is representing the sine of 45. And that's when we had a hypotenuse on our triangle 1. So that becomes the radius of this unit circle. All right, and keep in mind what square root of 2 over 2 is. It's about 0.7 as a decimal. Now, what holds true for this triangle holds true for all triangles that you can draw on the unit circle. But we're just going to concern ourselves with this 45-degree angle right now. Now, the other thing that we want to do is find more points on our unit circle, because each one of those coordinates that fit on that unit circle are going to be representing the cosine of that angle and the sine of that angle. So we expanded it out to go all the way around the circle. So if you look here at 0 degrees, your ordered pair is 1, 0. So 1's going to be your cosine and 0 is going to be your sine. Then we have the 45. Then at 90, we have the ordered pair 0, 1. So the 0 is going to be the cosine of 90 and the 1 is going to be the sine of 90. Then we went into quadrant 2. So this had the same coordinate as here. It's just simply a reflection over the y-axis, but this x value is negative in quadrant 2, and this one is positive. And then you can keep going around the circle and finding all your cosines and sines for different angles. Now, if you're looking at this unit circle, the domain is from -1 to 1. Your furthest to the left point is -1. The furthest to the right point is 1. So all of these values on the unit circle that are here are between -1 and 1. Which tells us that the cosine of an angle is going to be between -1 and 1, and so is the sine. Because on the range of this unit circle, you also have from -1 to 1, which is going to be your y values, which are going to be your sines. Okay, so now what we want to do is use our unit circle and find some ordered pairs. So if we have 0 degrees, we have a 0 for our sine. At 45, we found that the sine was square root of 2 over 2. And at 90, we said the sine was 1. Then at 135 degrees, we have square root of 2 over 2 again. Remember, we're still above the x-axis, so our y values are still positive. At 180, we're back to 0 again. Now, beyond 180, we're going to be below the x-axis, so we're going to have negative sine values, or negative y values. And then at 360, we're back to 0 again, so we have 0. Okay, now when we're talking about a sine graph, we want to graph that as a relationship between your angle measure and your output is your sine. Your angle measure is now your input values, and that's your domain. So we can actually put in any angles we want. We just were working between 0 and 360 on the unit circle, but we could go around the circle again, finding coterminal angles, which will have all the same sines and cosines as the original angles. We could even go counterclockwise and get some negative angles. And of course our range we said was between -1 and 1 for the sine. Okay, so let's go ahead and plot these points. So we had 0, 0, 45 and square root of 2 over 2, 90 and 1. And remember that we said the greatest value for a sine is 1. So from that point, it has to come back down. And then at 180, we have 0. And at -270, we have -1, which is our lowest point. So now our graph has to come back up again. And now all we need to do is connect our points with a smooth curve. Okay, now we need to put in some negative values. So we're going to go in the clockwise direction this time. So 0 is still 0. -45 is the same as 315 degrees. So we're going to get the negative values, negative square root of 2 over 2 for that one. And then -90 is the same as 270. So we're going to grab that angle, that sine value. And then we have -135, and -180 is the same as +180. -225 is the same as 135. -270 is the same as 90. And then we go all the way back to -360, which is the same as 0. So we have some more coordinates that we can plot on our sine graph. So now what we've done is completed 2 periods of the sine. One period would be going from 0 to 360, and the second period is going from -360 to 0. What you should also notice by looking at the sine curve is that it has origin symmetry, which means that it has 180-degree rotation symmetry about the origin. And when you have origin symmetry, you have a graph that is considered to be odd. Okay, so we did everything in degrees, but what we also want to do is be able to graph it in terms of radians. So we're going to convert each and every one of our angle measures into a radian measure. So 0 is just 0 radians. With 45, we're going to multiply by a conversion factor of pi over 180 and put it in lowest terms, so we have pi over 4. Now we're going to continue to multiply each one of these angles by pi over 180 and then putting them in lowest terms. Now the only change that you need to make on your graph is your x-axis. Just replace your angles with radian measures. So they're still going to be equally spaced apart, and you can just plot your points from there. So what I did was I marked every pi over 2 units, and then halfway in between them would be the pi over 4 units. And you've got your entire sine graph. All right, thank you for tuning in to Demystifying Math.